Hey, geometry. We are in Unit 1, Lesson 4. We're still doing construction techniques. This is construction techniques 2, equilateral triangles. Equilateral triangles, let's talk about that before we even get into anything else. Equilateral, I don't know why I'm not writing here. There we go. Equal length sides of a triangle. So if I drew a triangle, I could mark it, tick mark, tick mark, tick mark. That means each one of those sides has the same measurement. All right, so let's look at 4.1. Notice and wonder. Circles, circles, circles. Lots and lots of circles here. What do you notice? What do you wonder? Okay, this is where I love the discussion in the classroom, but we can't have it right now. So what do you notice? What do you wonder? I notice this beautiful flower here in the middle. And then I also can look at the bigger picture and I see another flower. I think they're beautiful. Let's see, there's other things the curriculum wants us to learn. Let's see if I can point some things out. You're looking along into my teacher's manual. Some intersection points are marked and others aren't. There are 7 overlapping circles. Really? Let's see, yep, not all the intersection spots are marked. Here we are. I see 1, 2, 3, 4, 5, 6 intersection marks. 1, 2, 3, 4, 5, 6, 7, one in the middle. So yep, 7 circles. There's a figure that looks like a 6-petaled flower in the center, and then you wonder, are all the circles the same size? How many kinds of shapes are there in the figures? If we connected other intersection points together, what kind of shapes could we make, right? All right, so let's move on. What polygons can you find? If we were in the classroom, we would be using a straight edge to draw at least 2 polygons in the figure. We can't, but I can do this. Nope, undo. I figured this out. Yep, Control-Z. I drew that. And what's really cool is if these are all the same size circles, that means from here to here is a radius of a circle, and then from here to here is a radius of a circle. So this is a measurement, and then we have a radius and a radius, so that's also another equal measurement. A radius and a radius, equal measurements. So we made an equilateral triangle here. What else can we see? I know if I draw this shape, that was a bad one. Okay, that would be a regular hexagon. Regular means that all the sides are the same shape. Hexagon means it's a 6-sided figure. Okay, so I didn't use a straight edge. I can come over to the students thing, and there we go. Here we can use the Polygon Tool because it says use the Polygon Tool. It looks like a triangle. Draw at least 2 polygons in the figure. So I'm going to use this tool and draw the same thing I drew before. I have to close the polygon. So there is my triangle. And then I can draw a regular hexagon too. So that's an equilateral triangle. We connect the center of each circle. And because I'm connecting the center of each circle and the circles are all the same measurement, then I know that it's a regular hexagon, that all of those sides are the same measurement. Do you notice how I look down at here and I'm supposed to be looking at you? I'm actually looking at myself, which is right down there on my computer. I need to look at the dot up here at you. I'm sorry, it's a bad habit. I'll try to remember. Let's see. Oh, I think we can make this a different color. I'm looking at that. Yep. So the regular hexagon is purple and the triangle is green. Awesome. So use the straight edge and compass moves to construct at least 2 equilateral triangles of different sizes. Let's see what we're doing here. I did look through the teacher's book, but I did this. So there's my regular hexagon on the inside. we did that. And now this one. Ooh, let's play. So, oops, not there. So yeah, I would love it if you would get into your student book and let's see. There we go. And practice this. So I need some other intersections, right? Okay, intersection of those two circles. Because it's really drawing polygons with dots with intersection points are way easier. So now I can draw lots of things. I can draw a little polygon, right? I can draw a big polygon. Cool. That one I should make pink. I could draw let's see. Let's go up there. This one's not regular, is it? Because the sides are not all equal, but still pretty cool. What happens if I connect all the dots on the outside? 1, 2, 3. Ooh, it's a big hexagon. Is this a regular hexagon? Are all my sides the same? I think it is. Okay, that's pretty cool. So that was in 4.3. Use a straight edge and compass to draw at least 2 equilateral triangles of different sizes. I want a little crazy. So that purple one's an equilateral triangle and the pink one is an equilateral triangle and nothing else is. Sorry about that. Got a little crazy. All right, summary. The straight edge tool allows us to construct lines and line segments, and the compass allows us to make circles with specific radius. With these tools, we can reason about distances and explain why certain shapes have certain properties. For example, when we construct a regular hexagon using circles of the same radius, we know all the sides have the same length because all the circles have the same size. The hexagon is called inscribed. Okay, that's a really important word because it fits inside the circle and every vertex of the hexagon is on the circle. So here we have, I'm pointing at the screen now, that's silly. Here we have an inscribed triangle. And because the triangle is inscribed in the circle, we say it's inscribed. If we connect every other point around the center of the circle, it forms an equilateral triangle. We can conjecture that this triangle has 3 congruent sides and 3 congruent angles because the entire construction seems to stay exactly whenever it's rotated a third of the full turn around the center. Okay, so that was your summary. And I'm still looking at that dot down in the corner. And then our glossary. Okay, I'm going to add a few things. Inscribed. I'm going to add, I think we already have circle and conjecture, but I'll make sure they're in there, okay? All right, constructions. I love that you're getting sort of an easy entry into geometry. All right, good job.